Good
Yeah,
morning, everyone. In the
yeah,
last sessions, I will take your question at the end, guys.
yeah.
Good morning, everyone. In the last session, we discussed about what is microservices architecture and how to develop our applications by using microservices architecture. So, in this, we discussed about what is a service registry, what is API gateway, what is admin server, what is a Jipkin server, what is admin server, what is a Jipkin server, and what is a config server. Those things we understood. And we also implemented load balancing in the microservices in the yesterday session. So load balancing we are using to distribute the request to multiple servers, and we also implemented API gateway. API gateway is going to act as API gateway is going to act as front controller, and it is entry point for our microservices based application. Any request is coming from outside, that request will be validated in the API gateway, and if the request is valid, then only it will process the request, otherwise it will stop the request. So in the API gateway we are going to implement filters and routings. So yesterday we implemented routings, which is used to forward the request to particular backend API, and we are implementing routings and filters. Filter, basically you can implement a global filter and you can validate your request. Here I am doing very basic validation. In the request, if the secret token comes, then only I will process, otherwise I will not process that request. Good. So today we are going to understand what is cloud config server and what is the purpose of going for cloud config server. So what is cloud config server and why we need to go for cloud config server? So anybody having any basic idea what is cloud config server? Do you know what is cloud config server and what is the purpose of this cloud config server, guys? What is cloud config server? Anybody having any idea on that?
Actually, the common properties which we are writing in all the services, so we can
Yes.
write an
External properties that
In
can able
our
to
application,
config
guys,
and run.
yeah, when we are working with application, we are configuring application config properties in the properties file or in the YML file. So in the Spring Boot application, by default one properties file will be created. You can convert that properties file into YML file also. So we are configuring our application properties, config properties in the properties file or in the YML file. What type of properties we will configure? These properties will be like this. Database properties will be available. SMTP properties will be available. Kafka properties will be available. And some application messages also will be available. So all these properties we are going to configure in the application.properties file or in the application.yml file. So when you configure them in the properties file or in the YML file, then they will be part of our application package. So in order to run our application, we are going to package our application as a jar file. Every Spring Boot application will be packaged as a jar file because it will execute from the main method. Application properties or application YML file will be packaged along with our application. It will be part of our jar file. So in the real time, how our application deployment process is going to happen, guys? So application code, as a developer, we are writing the code. That code will be available in the Git repository. Development team will write the code, and a development team will store that code into Git repository. Then operations team is going to take that code by using Jenkins. Okay, we are going to take that code by using Jenkins. Then we will build that code by using Maven. Jenkins will pull the code from the GitHub. Then it will communicate with the Maven in order to build that code. Then after Maven build got completed, Jenkins will perform code review by using SonarQube. After code review got completed, then for that code, security scan will happen by using Trivy. Security scan will happen on that code by using Trivy. Once all these scans are completed, then that code will be uploaded into Nexus or JFrog artifact repository. That code will be uploaded to JFrog repository, and once it is done, then finally that code will be packaged as a Docker image. So that code will be packaged as a Docker image. After the Docker image is created, finally that code will be deployed into Kubernetes. So in the real time, this much process will be available in order to deploy our application. So development team will write the code in the project and they will push that code into GitHub repository. Once the code is pushed to GitHub repository, we need to pull that code from the GitHub by using Jenkins CI/CD pipeline. Then Jenkins will communicate with the Maven in order to build that project. Then Maven will communicate with the SonarQube to perform the code review. Then it will talk to Trivy for security scan. Then it will upload the project jar file into JFrog repository. Then it will build a Docker image for our application. Then finally, that Docker image will be deployed in the Kubernetes cluster. So this much process will be available in order to build and deploy application build and deployment process. Application build and deployment process. So this is the process that we need to follow in the real time in order to deploy our application to the server. So code is available in the GitHub. We need to take the code from the GitHub by using Jenkins. Then we will build that code by using Maven. Then we need to review that code by using SonarQube. Then we need to perform security scan by using Trivy. Then we need to upload the code artifact into JFrog. Then we need to build a Docker image for our application. And we need to convert that image into execution by using Kubernetes. So here if you observe in our project, application properties file or application YML file is available. It is part of our project. So in that properties file or YML file, we are configuring database properties, SMTP properties, Kafka properties, and application messages also we are configuring. Now tomorrow, when you want to deploy your application, when you are packaging your application, that properties file also will be packaged. Okay, so if you see API gateway, inside this API gateway, there is one YML file is available. In this YML file, we are writing some configurations. So tomorrow, when we package this project, this YML file also will be part of the jar file. Application.properties file or application.yml file will be packaged along with our application. It will be part of our jar file. Suppose if I want to make any changes, to the properties file, some database properties I want to modify. If we want to make any changes to the properties, then we have to repackage our application and we have to redeploy our application. So if any changes required in the configuration properties, then we have to repeat the complete project build and deployment process, which is time consuming. So if you make a minor change in the properties file also, then you need to repeat the complete process. You need to take the latest code from the GitHub. You need to build that code by using Maven. You need to review that code by using Sonar. You need to perform security scans by using Trivy, and you need to upload the artifact into JFrog, and you need to build a Docker image, and you need to deploy that application in the Kubernetes cluster. So this complete process we need to repeat. When we are going for project build and deployment. So if I make a minor change in the properties file, again we need to repeat the complete process. We need to redeploy the entire application. That is time consuming process, and it is not recommended. So that is the reason it is not recommended to keep our YML files within the application. So we are writing database properties, SMTP properties, Kafka properties, everything inside our application.properties file or application.yml file. If you keep like that, tomorrow when you want to make some changes to the properties file or when you want to modify some properties in the YML, then you need to recompile, you need to repackage, you need to redeploy the application. Whatever the microservice is available, you need to repeat the complete process for the microservice if there is a minor change in the properties file. If code is changed, then okay, we have to do everything. If code modified, we have to do everything. If you modify the property also, you have to do everything. That is not recommended. So why this problem is coming? We are keeping the properties file within the application. So when you package this project as a jar file, this properties file, YML file also will go in the jar file. If you make any changes in the YML, again you need to create the jar. Again you need to deploy your application, which is time consuming process. Okay, to avoid this problem, we need to separate our project source code and our project configuration properties. Okay, guys, do you understand what is the problem if you are keeping the properties file or YML file within the application? Are you guys able to understand what is the problem if we are keeping project source code and project properties file at same place? Can you tell me what is the problem if you are combining the properties file and source code? Come on, guys.
Sir, we need to redeploy the application again. It will take time.
The entire application. We need to redeploy the entire application. So it is not recommended to keep the properties file or YML file within our application. So to avoid this problem, we have to separate our project source code and our project config property files. Okay, so to externalize config properties from the application, we are going to use cloud config server. So what is cloud config server? By using this cloud config server, we can make our application loosely coupled. By using cloud config server, we can make our application loosely coupled from the properties file and YML file. So how we are going to implement a cloud config server? Whatever the properties are required for my application, those properties I am going to keep in the GitHub repository. Okay, so GitHub repository I'm going to take. Suppose there is one application available, which is, for example, flights application available. So for flights application, one YML file is required, flights YML. Similarly, trains application is available. We are going to take this as trains.yml. And hotels application is available. For that, we are going to take a separate YML. So like this, for every project, separate YML file will be available, which contains database properties, SMTP properties, Kafka properties, Redis properties, whatever you want. Those things we are going to maintain in the GitHub repository. And we are going to create one config server application. We are going to create one config server application. This is another microservice. This config server is responsible to load the YML files from the GitHub repository. So whatever the projects, whatever the microservices are available, for our microservices, configuration properties, the YML files are properties file. Earlier, they are part of our project. If you keep them inside our project, then our project will be tightly coupled with the properties. Tomorrow, if you make any changes to the properties file or YML file, we need to redeploy, we need to build and deploy entire application, which is not recommended. To overcome that problem, we are going to use config server. By using this config server, we can separate the project source code and the properties. So how we are going to maintain the property files in the real time? The property files we are going to keep in the GitHub repository. So whatever the microservice available, with your microservice name, you will create a properties file. So flights available, flights.yml, flights API, flights microservice available. For that, I'm giving the file name as flights.yml. Trains API available, I'm giving the file name trains.yml. Hotels API available, I'm giving the name as hotels.yml. So now all these YML files will be loaded by our config server. All these YML files will be loaded by config server, and whatever the microservices are available, our microservices will act as a client for the config server. So for example, here flights service is available. Okay, and this flights service application is our microservice. That microservice will register with the config server. So our microservice will act as a config client now, config server client. Similarly, trains API is available, trains service available, one microservice. This microservice also will register with the config server. And similarly, hotels service is available. This is another application. This hotels service also going to register with the config server. It is also going to register with the config server. So like this, our microservices are going to register with the config server. Config server will get the YML files from the GitHub repository. Now for this flights service, microservice name we are going to configure, name is equal to flights. Based on our microservice name, config server will identify from which YML file it has to get the properties. So in the GitHub repository, there are 3 YML files available. So in the application, there are 3 microservices available. For which microservice, which YML file is required, it depends on name of the microservice. So my microservice name, I'm configuring as a trains. Then it will identify that. So then config server will identify that for the trains microservice, trains.yml file data is required. So this name, whatever the microservice name you are writing, that name should match with the file name in the GitHub repository. Here, hotels service is available. What is the name of the hotels service? Okay, name is equal to hotels. So with this hotels name, is there any YML file available? Yes, hotels.yml file is available. So like this, config server is going to load the configuration properties from outside. Now tomorrow, when you make the changes to the YML file, which are available in the GitHub repository, then you no need to redeploy your microservice. So your microservices are loosely coupled from the configuration properties by using config server. So which microservices you are developing? For those microservices, we need to assign one name. With that name, we need to create one YML file, and that YML file we are going to keep in the GitHub repository. And we are going to create one config server project. So that config server is going to load the properties from the GitHub repository. And our microservices will load the properties from the config server based on the name of the service. If your microservice name is flights, it will take flights.yml. Our microservice will not take from the GitHub directly. Our microservice will take the properties from the config server. Config server will take the properties from the GitHub repository. So with this, can we say our microservices are loosely coupled from the configuration properties? In the every project in the real time, we are going to follow the same approach.
Sir, one doubt regarding multiple database connection. How we will do, like flight is using a separate database and train service is using separate database.
Sir, multiple databases, that every microservice will communicate with its own database. That database properties you are going to write in your YML file.
So same way how we are using now with the flight name as flight and train name, same way database.
Yes,
will-
same database or multiple databases you can connect.
Okay.
Okay, perfect guys. Next one.
Sir, on the YML, we make the changes separately, sir, and those will be maintained separately on GitHub, separate from this microservice.
Yes, sir. Earlier, our YML files are available within the microservice, but
Right, sir.
from now onwards, YML files we should not keep within our project. YML files should be available outside of the project. If you keep the YML files outside of the project, what is the advantage?
Right, sir. We don't need to make the change again and again on the
We don't need to
entirely.
redeploy. We don't need to redeploy our application again and again. We don't need to redeploy our application again and again.
So these YMLs are separate microservice, sir, or is just standalone files, sir?
These are just files we are keeping in the GitHub repository.
Just GitHub. Okay.
For every microservice, a file will be available. So currently the files are available within our project, right? Application.yml available within our project. So if you keep the YML within the project, when you package, that YML also will go in the jar file. So if any changes we have done to the YML, again we need to create the new jar file. Again we need to redeploy the application. This is a complete process we have to repeat when you make a minor change in the properties file also. So that means our application is tightly coupled with the properties file or YML file. That is not recommended. So that's why we want to make our application loosely coupled with the YML files so that we can make the changes in the YML files without redeploying the application again and again. So how can we make our application loosely coupled with the YML file? That's where config server concept comes into picture. So how the config server is going to work? First, we need to identify what all the microservices we are developing. For those microservices, we need to assign one name, unique name we need to assign for every microservice. With that microservice name, we will create a file in the GitHub repository. That GitHub repository information we will give to the config server project. Here, config server is one microservice. This we need to develop now. We need to develop one microservice which will act as a config server. That config server will read the files from it will load the files from the GitHub repository and it will give to our microservices. Which file should be given to which microservice? That's where config server will identify name of the microservice. If this microservice name is flights, then it will give flights YML file to this microservice in the runtime. This microservice name is trains. It will take trains YML file, will give to train service. This microservice name is hotels. It will take hotels YML file, will give to that microservice. So our microservices are going to act as a client for the config server. Our microservices will act as a client for the config server. Okay. Now let me start with
Is that all these microservices and config server all are going to be hosted on the same server? They are in different servers.
It can be in the different. Every microservice will run in the different server. Config server will run in the one server.
So if the config server is crashed or it is not available, then the entire application will not work, right?
Yes, sir. You need to take care of a high availability. If a config server is not available, your microservices will not work.
So that is the main disadvantage of this way, right?
Yes. Now here,
sir, I have small doubt, sir.
Let me complete the topic. Any questions you can ask at the end. Okay. Config server is used to externalize config properties from the application, and we can use this cloud config server to make our application loosely coupled. And how to use this cloud config server? Cloud config server is part of Spring Cloud library. Cloud config server is part of the Spring Cloud library. How we have used Eureka server, CN client. Similarly, we are going to use cloud config server, which is part of Spring Cloud library. Okay. Now, when we are going for this config server application development, application properties files we will maintain in the GitHub repository, and config server will load them and will give to our microservices based on our microservice name. So when we want to implement config server in our microservices, application config properties files we will maintain in the GitHub repository, and the config server will load them and will give to our application based on the application name. So as I told you, so here microservice name, app name. So if you are configuring app name, if you are configuring the app name as flights, then it is going to identify flights.yml. So based on your application name, it will identify which YML file is required. So application name, if you are configuring as flights, then it will take flights.yml. So if your application name you are configuring as hotels, if your application name is hotels, then in the GitHub repository, there should be one YML file with a name called hotels.yml. If your microservice name is trains, then in the GitHub repository, there should be one YML file with a name called trains. Trains.yml file will be available. Our microservices will get the configuration properties from the config server, and the config server will get the properties from the GitHub repository. So as you see in the diagram, our microservices are going to get the properties from the config server based on the name of the microservice, and the config server will get the property files or YML files from the GitHub repository. Now, if you implement this kind of approach in your application, then what is the benefit we are getting? What is the advantage we have in this approach? Guys, what is the advantage we have in this approach?
Deployment single time deploy.
Application will be loosely coupled from the properties. Application will be loosely coupled from the properties. So what is the meaning of loosely coupled? Tomorrow, if we make any changes to our YML files, do I need to redeploy the entire application? Do I need to perform this process again if there is any change in the properties file? Guys, if there is any change in the properties file, do I need to redeploy this application, or I no need to redeploy this application?
No need to redeploy.
Do I need to redeploy this application, or I no need to redeploy this application?
No need to redeploy the application.
We no need to redeploy our application because earlier our properties are available within the project. Now we are separating the properties from the application, so we no need to redeploy our application. Okay, so we are trying to understand what is config server and why we need to go for config server in our application. So for every project, some properties configuration is required. Those can be database properties, those can be SMTP properties, those can be Kafka properties, or those can be application messages also. So as of now, whatever we are doing, the properties files, YML files, we kept inside the project only. If you keep inside the project, package, when we keep the properties file, YML file within the application, when we package our application, that jar file will contain the properties file also. If you want to make any changes, then we need to rebuild and redeploy the application. So that is a time-taking process. This much process will be available in order to build and deploy the application. So if you make a minor change also, you need to perform everything again and again. So which is a time-consuming process. So to avoid this problem, we are going to separate the properties from the application. For that, we are going to use config server concept. So cloud config server is part of Spring Cloud library. How that config server concept will work? If you see in the diagram, whatever the microservices are available, for every microservice, we will assign some name, and these microservices will register with the config server. Config server is another microservice, and the config server will load the properties files from the GitHub repository. So what we need to do now? First, we need to understand how to create the config server and how to register our microservices with the config server, and how to keep our YML files in the GitHub repository. Okay, so first let's understand how to develop a config server project. So developing config server. So first, you need to create one Git repository for your microservices related configuration files. Create a Git repository and keep YML files required for the microservices. Create Git repository and keep YML files required for the microservices. So we should keep the file name as a application name. When you are creating the YML files in the Git repository, you need to keep your file name as application name. So if your application name is greet, then file name should be greet.yml. If your application name is welcome, then the file name should be welcome.yml. So like this, you need to create one Git repository and you need to keep your YML files in the Git repository. I'm having one Git repository. You can also use the same Git repository. So if you go to this Git repository, I kept two YML files in the Git repository. One file name is welcome.yml, another file name is greet.yml. So here welcome.yml file available, message welcome to Ashok IT is available. And there is a file greet.yml is available, message is available as a good morning. For other microservices also, suppose some report service is available, all my configuration I kept in this file. So like this, for every project, one YML file we are going to maintain. So currently here welcome.yml, greet.yml is available. So in these YML files, one key value is available, message. In the welcome file, welcome to Ashok IT is available. And in the greet YML file, the message is available as good morning. So my GitHub repository is ready. So the first step that what you need to do, if you want to work with the config server applications, then you need to create a Git repository and you need to keep the microservices related configuration files in the GitHub. And you need to make sure whatever the file you are keeping, that file name should match with your microservice name. So the application name should match with the YML file name. So once it is done, then create the Spring Starter application with the config server dependency. You need to create one Spring Boot application, and for that application we need to specify cloud config server dependency. So let me create the application, file, new, Spring Starter project. So this project name I'm specifying as 07. I'm specifying the project name as 07 cloud config server. Specifying the application name as cloud config server. Now we need to select the dependencies here, guys. So what is the dependency? Config server. I'm selecting DevTools dependency and I'm selecting config server dependency. Cloud config server. Yes, config server is available. Config client is also available. So I'm using config server dependency. Click on next and click on finish. Cloud config server dependency I have selected. And once the project is created, now you need to write one annotation, enable config server. Enable config server annotation, we need to specify at the boot class, start class. So first set up your GitHub repository with all the YML files required for your microservices. Then create a boot application. Create a boot application with the below dependency. So that is cloud config server. Cloud config server. And I have added DevTools also. If you want to restart the server, then I added DevTools dependency also. Config server dependency we have added. So once we created the project, then we need to add this annotation at our boot start class. Go to config server, you check the pom.xml file. Go to config server, you check the pom.xml file. So cloud config server dependency is added and DevTools available, guys. That's it. So Spring Boot 3.3.3 version, Java 17 version. And go to this start class and write one annotation, that is enable config server. Writing one annotation called enable config server annotation we are writing. So with this, our config server is ready. Now we need to tell to this config server, we need to tell to the config server from which repository it has to load the properties. Okay, go to the YML file of this config server. Properties file is available. I'm changing that properties file to YML file. Properties file is changed to YML file. So this is our config server application. So config server application port number, I'm configuring server.port. Server.port. I'm giving some port number for the config server, something like this, 9093. Some port number I'm giving for the config server. And this config server should load the property files from the GitHub repository. From which Git repository it has to load the properties. So I need to specify that. For that we will use spring.cloud config.server.github. I want to load the properties from the GitHub repository. Okay, cloud config server.github.uri. What is the URI? What is your GitHub URI? From where you want to load your properties? Cloud config server git URI. So this is the URL of my GitHub repository where my configuration properties are available. Git URI, clone and start. Okay, clone and start that you can specify. So whenever the application is started, then immediately it is going to clone that GitHub repository. It will take the properties from the GitHub repository. So management security enabled false that we are going to specify, that is optional. Just management dot security we'll add the clicker, we'll see that. So currently we are configuring application name and we are configuring our GitHub repository URL. So config server should load the properties from the which GitHub repository, that URL I specified, and I configured some port number for this config server application. Okay, Spring application name, cloud config server git URI we specified, and the server port number also we have configured. Then what is the next step? Config server application is ready. Let us run the application, run our config server application, and let us see. Write these properties, configure below properties in the YML file. So what are the properties we are writing in the YML? A name is available for the config server and GitHub repository. From which GitHub repository? It should load our YML files. We are specifying that, and port number also we are configuring. Once it is done, then run our config server application. Once it is done, then let us run our config server application. Okay, let us see, is it going to work or not? Refresh, run as boot application. I'm running my cloud config server application. Yes, the application is started with embedded Tomcat container and it is running on the port number 9093. So very good. Our config server is ready. Next, we need to develop our config client, our microservice we need to develop. So our microservice is going to register with the config server. Config server is connected with the GitHub repository. Now our microservice will be available. Our microservice will register with the config server in order to get the configuration properties. So how to develop our config client development? Okay, so that means we are going to develop one microservice. That microservice we are going to act as a config client. Okay, so create a boot application with the web starter, config client dependency, and a DevTools dependency we are going to specify. Then create a REST controller. Create a REST controller with the required methods. Then configure config server details in our YML file. Run the application and test it. So we are going to run the application and we are going to test it. That means I want to develop one microservice which is going to act as a client for the config server, and based on the name of microservice, it should get the message from the config server. So if you see in our GitHub repository, YML files are available. Welcome.yml, greet.yml files are available. So welcome.yml, if the microservice name is welcome, then it will load this message from the welcome.yml. If that microservice name is greet, it will load the greet message, which is good morning. Now let me develop our client application. File, new, Spring Starter project, 08, config client application I am developing, cloud config client. Click on next. Now, what are the dependencies? DevTools dependency, WebStarter I am using, and config client dependency I am adding now. It should get the properties from the config server. So I'm adding config client dependency, and if required, you can add actuator also, right? DevTools, actuator, config client, and web dependencies I'm adding. Click on next and finish. Now, what we are going to do in this application, the project is created. The project is created. Now we need to create the REST controller with the required methods. We need to create a REST controller with the required methods. So let me create one REST controller in this project. Now I'm going to create a REST controller. So .REST package is available. So I'm creating a REST controller, which is message REST controller, So how to represent this class as a REST controller? To represent this class as a REST controller, we are going to use one annotation called @REST controller. Annotation will be available. So we are using one annotation called @REST controller. Now inside this REST controller, we can write the methods and we can read the properties. We can write the methods and we can read the properties by using this REST controller. Now, so what is the logic that we need to write in the REST controller? I will write one variable which is private string message. So from where we need to read this message? From the YML file. So if you see in the YML file, key message available. I want to read that key. For that, we will use a annotation called @value annotation $of message. So this is used to read the property from the YML file. But that YML file is available in which location? Is it available in our project? Is it available in the GitHub repository, guys? The YML file is available in our project, or the YML file is available in the GitHub repository. Whatever the message we are reading, that message is available in the YML. That YML file is available in our project, or is it available in the GitHub repository? That YML file is available in the GitHub repository. That YML file is available in the GitHub repository. Are you guys able to follow me? Now, let me write one method here, public string get message. Okay, whatever the message is coming from that, I'm going to return that same message. Whatever the message is coming, I'm going to return the same message. So I'm not writing any fancy logic here. I'm just getting the message from the YML file and I want to return that message. Let me map this method to a GET request by using @get mapping, then URL / That's it. So this is our client application, which is expecting the message from the YML file. That YML file is available in the Git repository. That Git repository will be taken care by config server. Our microservice will act as a client for the config server and it should get the properties from the config server. Are you guys able to follow me? What is the purpose of this value annotation? Which is used to read a property from the properties file. Are you clear? Which is used to read the property from the property file. It is used to read the property from the property file. It is used to read the property from the property file. Are you clear with my point? But where is the properties file available? Is it available in our system or is it available in our project or is it available Is it available in our project or is it available in GitHub repository? It is available in the GitHub repository. So that means our project should register with the config server. How to register our project with the config server? How to register our project with the config server? Okay, good. So to register our project with the config server, we will make some changes in the properties file. Let me convert this properties file to YML file. Application.properties file is converted to application.yml. So this is the name. We should give the name as welcome. Then it will read the welcome.yml. So I'm giving the application name as welcome so that it will read the welcome.yml. If I give the name as greet, then it will read the greet.yml data. If I give the name as welcome, it will read the welcome.yml data. So configure some port number for this one, server.port number. Default port also we can use, no problem. Server.port we are using. Server.port is equal to some 8081, or if you don't configure also no problem, default port will work. Now let me specify config server URL. Where is the config server available? Spring.config.import. Spring.config.import. Config server URL we are going to specify optional config server http://localhost:9094. 9094. So where your config server is running, what is the URL of the config server you need to specify, and your application name you need to specify. So what is the meaning of that? So we are trying to give that, where our config server is available, its URL. Config server running on which port number, guys? So if you see, our config server port number is available as 9093. Sorry. So our config server port number is 9093. For the client application, we are telling the URL of the config server. That means our microservice is going to communicate with the config server. Based on the application name, config server will give the YML file to our microservice. So we are separating our application source code and our application properties. Earlier, properties are available within the application. Now the properties are separated from the application by using config server concept. So I created one microservice, and for this microservice, I have given the name as a welcome, and I have given the config server URL. So what is the meaning of this? My microservice will communicate with the config server, and config server will understand my microservice name is welcome. Then config server will go to the GitHub repository and it will identify, is there any file available for welcome microservice? Yes, welcome.yml is available. So it will load the welcome.yml file data into my microservice. In that welcome.yml file, there is a key available message. That message key value is welcome to Ashok IT. So I need to get welcome to Ashok IT into this variable that I am sending as a response. So if my microservice name is welcome, it will get welcome to Ashok IT message from the welcome.yml. And if my microservice name is greet, it should get the greet.yml file data into our microservice. Now let me run my client application. So let us see. Our config client application is able to communicate with the config server, able to fetch the messages from the YML file, which is available in the Git repository or not. Let's try to understand. So if you observe, do I have any key called message in our YML file? In my client application, is there any message key available? No. Client application is having config server URL. Okay. And config server application is having GitHub repository URL. Inside that GitHub repository, my YML files available. Welcome.yml, greet.yml. Now I will run my client application and I will check, am I able to get the message from config server or not? So in my REST controller, I have taken one variable to understand from which YML file the data is coming. Key is message. In both YML, same key available, but values are different. Let me run my client application, run as boot application. Application failed to start. The spring.config.import property missing a config server entry. Add config spring.config.import config server property to your configuration. Spring cloud config enable is equal to false. Check enable if configuration is not required. Add spring config import optional config server instead. Spring.config.import optional config server. To disable this, check if configuration is not required. Spring.config.import optional config server. Sorry, there is a spelling mistake in the YML file, guys. Server, config server. It was typo. Yeah, refresh your application, then run this application, run as boot application. I'm trying to run my client application. Config server is already running. Now I am running config client. Yes. Config client application is getting started. Yes. If you see the console, the config client application fetching the config server from 9093. I configured config server URL in the client application. So local environment name welcome it is taking. So default profile it is taking. The client application running on the port number 8080. Actuator is enabled beneath the base path. Actuator enabled. Now application is running with 8080 port number. Now let me show you the console of the config server. In the config server console, if you observe, adding property source YML via location, the config repository. Once my client application is started, config server is fetching the properties from the GitHub repository. Okay, client application started. So client application is having the URL of the config server application. Config server is having the URL of the GitHub repository. Now let me access our microservice. Microservice name is welcome. Localhost 8080. Just send the request. Am I able to get the message? Welcome to Ashok IT. But actually, where is this message configured, guys? This message is configured in the GitHub repository welcome.yml. The key is message, value is welcome to Ashok IT. Now, when I access my REST controller getting the message from where? It is getting from the config server. How the config server is giving only this file message? Why not greet message? Depends on the application name. Now, if I change my application name from welcome to greet, if I change my application name to greet, and if I restart my application, now you check it. So if I restart my application, now I am changing the name to greet. Now let me run this microservice. Based on the application name, it will understand from which YML file it has to get the data. From which YML file it has to get the data, that it depends on the name of the application. Earlier, my application name was welcome. So it loaded welcome file message. Welcome YML message it loaded. Config server loaded welcome YML message. Now I changed the application name to greet. Now send the request again. Now we are getting good morning. So with this, are you able to understand? Config server loading the data from the YML file based on name of the application. If the application name is welcome, I'm getting one message called welcome to Ashok IT. If the application name is greet, then I'm getting a different message, good morning. Why that difference is there? For the application name welcome YML file is available. For application greet YML file is available. So now my application loading the properties from the config server. So my microservice is acting as a config client. It is loading the properties from the config server. Config server loading the properties from the GitHub repository. So can we say our application is loosely coupled? Can we say our application is loosely coupled from the configuration properties? So currently in this YML, I just configured a message, key value. Okay, so database properties, SMTP properties, application messages, you can configure. You can see one of the YML auth service. So admin client URL, data source details, JPA details, actuator details, application message like this. Everything we will keep in the YML file. That YML file is available in the Git repository. If your microservice name is auth service, then it will load this YML data. If your microservice name is a cart service, it will load the cart service YML data. Here, cart messages, data source properties are available. Order service is available. So when microservice name is order service, then it will load the data from this YML. Payment service available, product service available, report service available, like this. Based on the name of the microservice, it is going to load the YML file data. So tomorrow, if I make any changes to this YML file, do I need to redeploy my microservice or not required? If I make any change to my YML file, do I need to redeploy my microservice or it's not required? It's not required. Why we no need to redeploy? Why we no need to redeploy? Because YML file is not in the project. YML file is available in the GitHub. How these YML files are loaded into our project, guys? Who is loading these YML files into our project? Programmer is loading or config server is loading? Programmer is loading these YML files into our project or config server is loading these YMLs into our project? Config server loading these YMLs into our project. Okay, so this is how you are going to configure the config server details in the YML file. So this is our REST controller that what I have created. So in this REST controller, I'm just getting a message key and that value is stored into a variable and that variable I'm returning as a response. How I developed my configure client application. I created one boot application with these dependencies, web starter, config client and dev tools. Then I created one REST controller with the required methods. Here I am getting a message variable. Then I am giving the URL of my config server in the client application. Then I am running the application and I am able to access my method. If my application name is welcome, it will load the data from the welcome YML. Welcome message will come. If I give the application name as greet, then it will give the greet message. Like this, in the real time, multiple microservices will be available. For every microservice, a separate YML file will be available. One thing that you need to remember, our whatever the name we are giving for the microservice, whatever the name, application name we are giving, that name should match with the file name. Then only config server will understand for which microservice, which YML file should be loaded. So if your application name is flights, the file name should be flights.yml. If your application name is trains, it should be trains.yml. If it is hotels, it should be hotels.yml. If it is order service, order service.yml. If you see in my GitHub repository, auth service YML, cart service YML, and payment service YML, product service, report service. For e-commerce application, I created several YML files in the config server. So in the JRTP, major project we are going to develop e-commerce application. For that e-commerce application, several microservices available. For every microservice, a separate YML file I have created in the GitHub repository. So these YML files will be loaded by my config server. My actual microservices will load the properties from the config server. So my microservices are loosely coupled from the config properties. Any database property, SMTP properties, Kafka, Redis, those properties are in the GitHub repository. My microservices are loosely coupled. Tomorrow, if any changes required for the properties, I no need to redeploy my microservice. I no need to redeploy my microservice. Are you clear with my point? Now I am giving you one task. If I change a property in the GitHub repository, will it reflect automatically or it will not reflect automatically? So my GitHub repository is available. So welcome.yml, greet.yml is available. So here I'm giving a message, welcome to Ashok IT, welcome to Ashok IT software training. Now I am updating the message in the GitHub repository. If I update this message in the GitHub repository, will it directly reflect in our application or it will not reflect in our application, guys? The file application name is welcome. So in the welcome to Ashok IT is available. Okay. Now if I update this application, if I update this property, will it reflect in the client application or will not reflect? Will it reload the changes in the properties file? Is my application going to reload the changes in the properties file or it will not reload the changes in the properties file? It will reflect, it will not reflect. Directly it will not reflect. Okay, let us see this. First, welcome application we are loading. Welcome to software training. My client application started. Now I will go and change the property file. Welcome to Ashok IT software training institute. Welcome to Ashok IT software training institute. Okay, Hyderabad. Something like this. My application started. The message is coming like this. Software training is coming in the bracket. After my application started, I modified a message. I am giving the message Software Training Institute Hyderabad. Update this file in the GitHub repository. After updating this file in the GitHub repository, let us send a request. Updated message is coming, old message only coming. Whatever the change I have done in the YML file, is that change reflecting in the client application or the change not reflecting in the client application? Then what we need to do to reflect? Is it loading the latest messages from the Git repository or it is not loading the latest messages from the Git repository? Is it loading the latest messages from the Git repository? It is not loading latest messages from the Git repository. Then what we need to do in order to reload the changes from the Git repository in our microservice? There are two ways. You need to restart the application. You need to restart the application. Or what is the another approach? Two ways we can do. If I stop and start my application, then latest properties will be loaded, but which is not recommended. Which is not recommended. So if I stop and start the application, latest properties will be loaded. But in the real time, is it recommended to stop and start the applications? Is it recommended to stop and start the applications? No. Then what is the alternate? To reload the latest properties. Without restarting the application, it should reload the latest properties. It should reload the latest properties. Can you do some analysis on that? Can you do some analysis on that part? How to reload the properties? How to reload the properties dynamically? How to reload the properties dynamically? Come on, guys. How to reload the properties dynamically? I will give the clue. By using actuator, we can achieve that. By using actuator, we can achieve that. Without restarting the server also, we can reload our properties. Without restarting our application, we can reload our properties by using actuator. Yes or no? You understand what is the problem we are facing now? We are able to achieve loosely coupling. Our properties are separated from the project. Our properties are separated from the project. But what is the problem we are having now? What is the problem we are having? It is not reloading the properties. It is not reloading the properties. So how to reload the properties when there are some changes? When there are some changes, how can we reload those properties? When there are some changes available, how we can reload those properties? When the application started, whatever the properties are available, it is taking those properties. But after my application started, there are some changes to the GitHub repository. There are some changes in the GitHub repository. Those changes are not reflecting in my client application. Those changes are not reflecting in my client application. So what we need to do for that? Yeah. So the applications are not loading the changes. So what we need to do in order to reload the properties? You got any solution, or shall I tell the solution for that? You got any solution, or shall I tell the solution for that? Yeah, so the solution is very simple, guys. We need to do three things in order to reload. How to reload? How to reload properties dynamically? How to reload the properties dynamically? So when I change the property in the GitHub repository, it is not reflecting in the client application. So you need to stop the project, then only the property will be loaded. So how to reload the properties dynamically? Now let me show you how to reload the properties dynamically. First one, configure refresh scope annotation at REST controller class. And the next one, enable actuator endpoint, which is refresh. Third one, send post request to actuator endpoint refresh from the postman. So in order to reload the properties dynamically, how to reload properties dynamically using config server? So what you need to do is you need to make three changes now. If you make these three changes, then your properties will be reloaded dynamically. So first thing, configure refresh scope annotation at the REST controller. So this is our REST controller. Here, let us write one annotation called @refresh scope annotation. We are writing an annotation called refresh scope annotation. Then go to YML file. Inside this YML file, in the client YML file, you need to enable actuator refresh scope. How to enable that? Management dot endpoint dot endpoints dot web dot exposure dot include web dot exposure dot include. You need to include one endpoint which is called refresh. You need to enable one endpoint called refresh endpoint. Okay, that's it. So which application want to reload the properties? In that application REST controller, you configure one annotation called refresh scope annotation, and in that client application YML file, you configure this actuator refresh endpoint. That is the reason when I am creating the client application, I added actuators dependency also. Okay, so when I am creating the client application, I have added actuator dependency also, so that we can reload the properties dynamically without redeploying the application. So what is the change I have done? I configured annotation called refresh scope annotation, and I configured refresh endpoint, actuator endpoint I have enabled. That is a post method endpoint, guys. Now let me run this application, refresh the project, run as boot application. I'm running my project. First, let me access the existing message. Then I will change the message and I will reload it. Yes, my client application is started. Clear this. Go to this application, access. The message is coming as welcome to Ashok IT, guys. The message is coming as welcome to Ashok IT. Go to this properties file, edit this. Welcome to Ashok IT available. So I'm writing software training institute. Very good. I'm updating this message in the Git repository. When I update this message in the Git repository, when I send the request, is it loading the latest message from the Git repository? It is not loading the latest message from the Git repository. Guys, is it loading latest message from the Git repository? Not loading the latest message. It is not loading the latest message. So then what we need to do? We need to refresh. How to do the refresh? Actuator refresh we enable. Localhost colon 8080 actuator refresh. Send it. I have sent the request in order to refresh. So configure client, okay, 200 response, okay, refreshed. Now send the request again. Now are you getting the latest message now? After refreshing, are we able to get the latest message? Did I restart my server? Am I restarting my server? Without restarting my server, am I able to access? Am I restarting my server? Without restarting also, I'm able to get the latest messages. Yes, can I show you once again? Yeah, so there is a spelling mistake in the message. Okay, let me correct it. Ashok IT Software Training Institute, Hyderabad. Yes, I corrected the spelling mistake and I added Hyderabad, commit it. I made the changes to the Git repository YML file. Now send the request. Still we are getting old message only because property files are not refreshed. How to refresh the property files? We already configured actuator refresh endpoint. Now go to your Postman. Localhost code. This is client application URL. Configure client URL. Actuator/refresh. Send a request. So this request is used to refresh the properties from the config server. Yes, we are able to do the refresh. Once the refresh is completed, send the request. Now, am I able to get the latest message now? So do I need to restart the servers? Do I need to redeploy the application if there are any changes in the properties file? Not required. So now tell me, keeping the properties file in the config server is recommended or keeping the properties file within the application is recommended? If I keep the properties file within the application, can we achieve this? If I keep my properties within the application, can we achieve this loosely coupling? No. So in the real time, in every project, this config server concept will be used so that our application will be loosely coupled from the properties. Now, practically we are able to see the application, our microservice connected to the config server. Config server is connected to the GitHub repository. Our microservice related YML files are available in the GitHub repository. So our microservice will connect with the config server URL. Config server will connect with the GitHub repository URL. Based on the name of the microservice, it will give the YML file from the config server. If any changes happen to the YML file, so you can use actuator refresh endpoint and we can reload the latest data from the YML file. So we are able to do that. So how we are able to reload those YML file data? Configure refresh scope annotation at the REST controller class level. Enable actuator endpoint refresh. How to reload config properties dynamically. So we need to make below 3 changes in the config client application. We need to make below 3 changes. We need to make below 3 changes to reload latest config props. Okay, configure refresh scope annotation at the REST controller class, then enable actuator endpoint called refresh, then send post request to the actuator endpoint refresh from the postman. Then after refresh, check your application giving latest data or not. Check your test your application. After refresh, test your application. So before refreshing, I was getting a different message. After refresh, I'm getting the before refresh, old message was coming. After refresh, the latest message is coming. So if you are having admin server, so this actuator refresh endpoint you can access from the admin server also. You don't need to send it from the postman. So if your application is registered with the admin server, then this refresh endpoint you can access from the admin server also. I hope you understood what is a config server and why we need to go for config server, and what is the advantage of the config server and how to work with the config server in the microservices. Config server is mainly used to reload the config properties from GitHub repository. It is used to make our application loosely coupled from the config properties. Right? Yes. So how to develop the config server and how to develop the config client and how to reload the config properties dynamically also we are able to understand. Very good. Thank you guys. So with this, we completed our microservices discussion. Whatever we planned for Saturday, Sunday, 2 more classes extra I have taken. And as of now, we understood how to develop a project with microservices architecture. Okay. So here we are able to understand service registry and admin server, Jipkin server, APIs development, inter-service communication, config server, and API gateway also we have completed. Thank you guys. So with this, I'm stopping for today.